All right, so today we're going to learn all about the binomial theorem. So our binomial theorem is used when we have something like this, okay, nj. So if we have something like this, what that means is that we're going to be taking n factorial divided by j factorial times n minus j factorial. Now this is used in a lot of different things. We're going to learn first, how do we solve this, right? So here's some examples. How do I find that answer? Okay, and then we're also going to use it in different types of problems. Now this is very common in the math world. You would see this in statistics, you would see this in lots of different places, not just in the ways that we're using it today. Okay, so the first one that it says is for 1. Okay, sometimes we say 4, choose 1. So it's 4 factorial on the top over 1 factorial times 4 minus 1 factorial. Okay, now that would be 4 factorial over 1 factorial times 3 factorial. Then remember, we learned how to simplify these. 4 factorial could just be 4 times 3 factorial. 1 factorial is just 1 times 3 factorial. Those 3 factorials cancel out, and I'm just left with 4. All right, so if you had to do that by hand, you could. Okay, number 2, we've got 9 factorial over 8 factorial times 9 minus 8, which would be 1 factorial. Once again, 9 could be written as 9 times 8 over 8. Those cancel out, just leaving us with 9. Okay, we got 35, 15, so 35 factorial over 15 factorial times 35 minus 15, which would be 20 factorial. Okay, so 35 could be 35 times 34 times 33, blah, 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 all the way to 20, and then that 20 factorial could cancel out. This is still going to be a lot of work by hand, so let's just plug that into our calculators. So remember to get the factorial button. We press math, go over to probability, and then it's the fourth one down. So 35 factorial over 15 times 20. We get this really big number. What's that? Like 3 billion, 3.2 billion? It's a really big number. Okay, now you can also find these answers by using a different button on your calculator. So if I typed in 4 and I went to math and I went to probability, but if I do this number 3, so if I go math and then probability, PRB, and then go down to the NCR, and then type in 1, our calculator will do that work for us. It's called 4 choose, that's why it's a C, 4 choose 1. Okay, so then I could do this problem too. 9, math, probability, choose 8, I get 9. Same thing, 35, math, probability, 15, I get that 1.2 billion number. Okay, so this is called the binomial theorem, and we're going to use it to solve some problems. So the next thing we're going to talk about is what's called the Pascal triangle. So the Pascal triangle was named after this guy Pascal, who lived back in the 1600s. Looks like he didn't live very long, maybe 40 years or so. He was a French mathematician. Okay, so he made up a lot of mathematics that we use today. The Pascal triangle has 1s down its sides, and to get any other entry, add the 2 nearest entries above it. Okay, so for example, we start with 1. It's going to be a triangle. So now we're going to go out 1, 1. Okay, now the next one always starts with 1. To get this number, we add these 2. So 1 plus 1 would give us 2, and then 1 on the outside. Okay, 1 on the outside again. 1 plus 2 gives us 3. 2 plus 1 gives us 3. 1 on the outside. Okay, and we go all the way down. So 1. 1 plus 3, 4. 3 plus 3, 6. 3 plus 1, 4. 1. And we can keep going as long as you want. Okay, this technically goes on for infinity. I'm just going to do a few more. Maybe one more. Okay, and like I said, this goes on forever. Now, why is this triangle important, this Pascal triangle? Well, this Pascal triangle actually has a lot of different things that it's helpful for. One of the things that it's helpful for is expanding our binomials. Okay, so this would be, this row here is when n equals 1. This row here is when n equals 2, and so on. So the nice thing is that if I ask you to expand x plus 4 to the 4th, right, what does that mean? Well, it technically means take x plus 4, or x plus y times x plus y times x plus y times x plus y, right? So that would be a lot of distributing. I would have to double distribute the x plus y, have to just double distribute the x plus y, then I'd have to take those two answers and distribute those. Okay, so that's a lot of work. However, because of our Pascal triangle, it actually becomes a lot easier. So, because our exponent is 4, our coefficients are going to be these numbers here. Okay, so because n is 4, we're going to use this row to help us solve this. Okay, now, our first term, because n is 4, is 1. Now, every term after that has an x and a y term. And the way we determine the exponents is that the first one is going to start with 4 and descend. The y is going to start with 0 and get bigger, ascend. So we start with 1, x to the 4th, y to the 0, plus, then the next number, 4. Now remember, the x is going to get smaller, the y is going to get bigger. So this is going to become a 3, the y is going to become a 1. Okay, now the next term is 6. The x is going to get smaller, the y is going to get bigger. So the x is going to change to a 2, the y is also going to be a 2. Okay, the next number, 4. X is going to get smaller, y is going to get bigger. Okay, the next number, 1. X is going to become smaller, so I got all the way to 0, and y is going to get bigger. Okay, so by the end, we should have x being at 0 and y being at 4. Beginning, x started at 4, y beginning at 0. So this is our final answer, except of course we have to simplify. Y to the 0 is just 1. So I've got 1 times x to the 4th, so that's just x to the 4th, plus 4x to the 3rd y, plus 6x squared y squared, plus 4xy cubed, plus 1. X times to the 0 is just 1, y to the 4th, so I could really just make this y to the 4th. So look at that. We just got what x plus y to the 4th was without having to multiply 4 different times, right? We didn't have to double distribute. We could use our Pascal's triangle. Okay, so on the test, if I gave you this problem and I said, expand x plus y to the 4th, what you would do off to the side is you would draw your Pascal triangle, right? You would just add, like we just did now, off to the side until you get to n equals 4. Use these numbers and expand. Okay, so let's do another one. The next problem here is x minus 3 to the 5th power. So if I wanted to expand that, I would need to use my Pascal triangle for the 5th, for n equals 5, right? So if this was on the test, I'd go off to the corner, I'd go 1, 1, 1, 2, 1, and we'd go all the way down. Okay, now we already did that, so I'm just going to look at what ours is. So n to the 5 is this row. So it goes 1, 5, 10, 10, 5, 1. So 1, 5, 10, 10, 5, 1. So that's what we're going to use. So we're going to start with 1. Now our first term here is x. Our second term is negative 3. Now x is going to be to the highest exponent. Negative 3 is going to be to the lowest exponent. Plus, next number is 5. X is going to be 1 lower. Y, negative 3, is going to be 1 bigger. Next is 10. X is going to be 1 lower. Negative 3 is going to be 1 higher. Next number is 10 again. X is going to be 1 lower. Negative 3 is going to be 1 higher. Next number is 5. X is going to be 1 lower. Negative 3 is going to be 1 higher. Lastly, 1. X is down to 0. Perfect. Negative 3 is up to 5. Perfect. Okay, if you notice, these always add to 5. Okay, they should always add to 5, or whatever your exponent is. So let's simplify. 1 times x to the 5th, negative 3 to the 0. Well, negative 3 to the 0 is just 1, so all I have left is x to the 5th. Now here I've got 5 times negative 3 to the 1, so that'd be negative 15, x to the 4. Here I've got 10 times negative 3 squared, so that would be plus 90, x to the 3rd. I've got 10 times negative 3 cubed, that would be negative 270, x squared. We've got 5 times negative 3 to the 4. 3 to the 4 is 81, times 5 is 405, so plus 405 x. And then lastly, 1 times x to the 0 means there's no x term, negative 3 to the 5th. So negative 3 to the 5th power is negative 243. So that is our answer. We were able to expand that. Remember, this is just multiplying x minus 3 5 times. So typically I would have to double distribute a ton of times. So I would like you guys to try this one on your own. And then pause it, try it on your own, and then unpause and check your answer. I'm going to have my work here. When you unpause. All right, so if you paused and tried this one on your own, this is what your final answer should have been, right? So 3y starts with the highest exponent, negative 2 starts with the lowest exponent, 3y makes its way down, negative 2 gets a little higher each time, and then we used our 1, 4, 6, 1, 4 from our Pascal triangle. Okay, now, one thing that I didn't really explain before, because the Pascal triangle is so nice, is that we could really get these numbers here by using our binomial theorem, by using this. Okay, but it's not really needed, to be honest, when we're using our Pascal triangle. Okay, however, it is much nicer if I'm just asking for a specific term. So if I want to know the 5th term in the sequence, then we can use our binomial theorem. So, for example, if I said I want to know the 4th term of this sequence, right? So we've got 2x plus 3 to the 5th power. I want to know if I went through and I found this whole answer, like this is up here. If I went to the 1, 2, 3, 4th term, so this guy right here, what would that answer be? So I don't need to know all of it. I just want to know this number right here. And, well, could you go through and do the whole thing? You could, but that's going to take a lot of time. Okay, so if I want to know the 4th term of this sequence, then we can use our binomial theorem. So the way we start our binomial theorem is we say, well, our exponent is going to be the first number in our binomial here. And then this number is always 1 less than the term I want to find. So because this is the 4th term, I'm going to do 4 minus 1, so this is going to be 5, choose 3. So 5 is the exponent, and because it's the 4th term, I'm going to do 1 less than that. Okay, now that's always going to be times 2x to the something, and then 3 to the something, right? So I need to figure out what would those exponents be if I went 4 terms in. Okay, well remember, these two always have to add to our top exponent. Now the second term is the one that's getting bigger, right? So if I use this number, that's going to tell me what number I'm at for my second term, because that's the one that's getting bigger. Well, these two exponents have to add to 5. So if this one is 3, then that means this one has to be 2. Okay, well now I can just go through and simplify. So remember, we could do this by doing 5 math probability choose 3. That tells us it's 10. 2 squared would be 4x squared, and 3 cubed is 27. So now I can do 10 times 4 times 27, which gives me 4,320 x squared. Right, so if I went into the fourth term of this answer, that would be the answer if I went 4 terms in. Okay, so let's do another one. So this one. This problem, we want to find the coefficient of y to the 10th for the expansion of this. So for this one, we have to think a little bit harder because it's not asking for a specific term. So we have to kind of think this one through to figure out if I wanted it to be y to the 10th, what term would that be? Okay, well, because this is a 6, we know the top number here is going to be 6. But I need to figure out what term it is so that I can have that number there. This one's going to be 3y to the something. This is going to be negative y squared to the something. Okay, so I need to figure out this so that I know what each of these exponents are going to be. So let's just say we were going to start this problem. Okay, so this is us trying to figure it out down here. Well, the first term would be 3y to the highest exponent, which would be 6, times negative y squared to the 0. So what would that give us? How many y's would we have? Well, we would have y to the 6th, and then y 2 times 0 would be 0, and y to the 0 is just 1, so that cancels out. So term 1 is y to the 6th. Okay, now term 2 would be 3y to the 5th power, negative y squared to the 1. Okay, well that would be 5. This would be 2. 5 plus 2 is 7. So we know the next term would be to the 7th. So it kind of looks like it's going up 1 each time, but let's do one more term and see if this one is an 8. So we would have 3y to the 4, negative y squared to the 2. So that would be 4, 4, which would give us 8. So it is going up by 1 each time. So the next term would be y to the 9. The next term would be y to the 10th. So that means this is the 1, 2, 3, 4, 5th term is going to be y to the 10th. So this is going to be our 5th term is what I'm finding. So this is going to be a 4. Now this 4 becomes the exponent here. Now remember, these two exponents have to add to 6, which means this one has to be a 2. So now I can go through and find my final answer. Now this one is just asking for the coefficient, which means I just want to know what number. But let's go ahead and find that. So we're going to do 6, math, choose 4. That gives us 15, 9y squared. Okay, now negative to the 4th power is going to become positive. And then remember, when we have power to a power, we multiply. So that will become y to the 8th. So I've got 9 times 15 times positive 1 would be 135. Y to the 10. Because remember, when we multiply, we add our exponents. The problem did just ask for the coefficient, which means our final answer would be 135.